Okay, these are the notes for 1.4 on extrema and average rate of change. So first thing we're going to look at is when a function is increasing, decreasing, and constant. Anytime we're looking at what the graph is doing, we're looking from left to right on the graph, and we're going to use a description using the x values to determine the interval on which it is doing one of those things. So first it says a function is increasing on an interval if and only if for 2 points a positive change in x results in a positive change in f of x. So what that means is the further right you go on the graph, the y values are increasing, okay? So if you look from left to right on the graph is going up, then it would be called increasing. If you're looking from left to right and the values are going down, then it is decreasing. So it says a function is decreasing on an interval if and only if for any 2 points a positive change in x results in a negative change in f of x or in y. Okay, so we're always reading left to right, and we're going to give an interval for which the function is changing. Okay, and then the last option is when a function is constant. Something is constant, it doesn't change value. So as you go from left to right on the graph, if the y value is staying exactly the same, then it's constant. A function is constant on an interval if and only if for any 2 points a positive change in x results in a 0 change in f of x. So if the y value doesn't change, then it's constant. Okay, so on example 1, it says use the graph of this function to estimate intervals to the nearest 1/2 unit on which the function is increasing, decreasing, or constant. So we're going to look at the graph and determine when it's increasing, when it's decreasing, or constant, and then we're going to give an interval to the nearest half unit. Okay, so that means we're looking at the x values on this graph and trying to narrow down where it's doing what. So I'm looking at this graph and I can see that there's 2 things happening. Okay, there's this yellow section and then it turns, and we've got this green section on the graph. So in the yellow section from left to right, these values are going down. Don't look at the arrows, look at from left to right, what is the function doing? So the further up this graph goes, the further left it's going to go, and it's going to keep going left to negative infinity. So this graph is decreasing from negative infinity, and then as I'm going across the x-axis, when I get to 0 on the x-axis, it actually turns, and it starts going up. So from negative infinity to 0 on the x-axis, this function is decreasing. Then at 0, it turns, and it starts increasing from left to right. So then I would say that it's increasing from 0 to positive infinity, because the further up it goes, the further right it's going to go as well. Okay, let's look at another example, number 2. So same thing, we want to determine when is the function increasing, decreasing, or constant. So I can see that there's kind of 3 sections on this graph. So I've got this first section, a middle section, and then this third section. So if I look at the yellow section of this graph, it's very similar to the last example. The further left this graph goes, the further up it's going to go. So this graph would be decreasing, again, from negative infinity up until the bottom of that turning point down there. And I would say that that point is about negative 0.5. So decreasing from negative infinity to negative 0.5. Then it turns, and we can see that from left to right at that negative 0.5 spot, it starts going up. So that would be increasing then from negative 0.5. And then on the other side of that, where it starts to turn again, that's about positive 0.5. So then the last purple section, we can see that it starts decreasing again. So back in my decreasing, I'm going to put from positive 0.5 all the way to positive infinity. Okay, next we're going to look at relative and absolute extrema, and that has to do with maximums and minimums on a graph. So there's two different types of maximums. There's a relative maximum, which means on an interval on the graph, I'm looking at a certain spot and this looks like the highest spot in that section of the graph. That would be a relative maximum. If I'm looking at the graph as a whole, then any spot on the graph that is the very highest spot would be the absolute maximum. So you can see in this picture to the right, the first point at A is a relative maximum in that little bitty section there. I could say from 0 to B, or a little past A, that there's a maximum kind of in this range. But at point B, that is the very highest that this graph gets, so it is the absolute maximum. Same thing with a relative minimum and an absolute minimum. So a relative minimum is just in a small section of the graph. This might be the lowest point. But then overall, if there's a very lowest point, that would be the absolute minimum. Okay, so let's look at an example with minimums and maximums. So I have this function and lots of stuff happening here. First thing I want to look at is any points, any turning points on the graph that might be minimums or maximums, and just kind of identify those points on the graph. So I see this green point and this purple point might be good spots on the graph to talk about minimums and maximums. Okay, so I kind of feel like, and notice on this graph that the x-axis goes by 2's. I feel like that there is a minimum somewhere in between -2 and 0. I may not know exactly where that value is on the x-axis, but I think it's somewhere in between -2 and 0. And then I feel like that purple point is a relative maximum somewhere in between 1 and 3. I could even say between 0 and 4 if I wanted to, but I want to try to narrow it down as much as possible. So these are both relative minimums and maximums. Now in this graph, since this graph continues up infinitely and down infinitely on the other side, this graph will have no absolute minimums or maximums because it's going to continue in both directions infinitely. So now what we want to do is we're going to use the equation in our calculator to kind of narrow down where the minimum and maximum is and what the value is at that point. So what I would do is I would type this equation in y equals, and then we're going to go to our table to find the values for this function. And I'm going to create a table over here, and I'm going to pick some x values to plug into my equation that range from -2 to 0. And I'm going to go in increments of 1/2. So if you want your table to go in increments of 1/2, you need to change the table setting on your calculator. Go to second window, and you'll change the table start to -2, and then the change in table to be 0.5. Then when you go back to your table, you should be able to see these numbers clearly. Okay, so here are the values that I get from my calculator. 18, -5.9, -7, -2.7, and 0. What I'm looking for is, I already said, hey, I think there's a spot somewhere in this section of the graph that is a relative minimum, the lowest point on the graph. So I'm looking at those y values, and I want to see which of these is the lowest number. Well, that's -7 is the lowest. So that means that there is a minimum at -7, or sorry, the minimum value equals -7 at x equals -1. Okay, we're going to do the same thing for the relative max. I'm going to pick numbers from 1 to 3 in increments of 1/2. So you should be able to scroll down on your table and find these values. 3, 8.2, 14, 9.8, and negative 27. So this time, though, I'm looking for a relative max. So I'm looking for the highest y value in this chart. The highest y value is 14. So that means our max equals 14, and that is at x equals 2. Okay, so if this graph hadn't continued up and down in both directions, we could look for an absolute minimum or maximum. But in this case, there wasn't one. We could only look at relative minimums and maximums on certain points of the graph. Okay, last thing we're going to talk about is the average rate of change. An average rate of change is just a fancy word for slope of a line. So way back in Algebra 1, you learned that the slope of a line is between 2 points. It's always rise over run. You learned y2 minus y1 over x2 minus x1. Well, this is the same thing. The average rate of change means that somewhere on the graph, they're going to pick 2 points, and they want us to find the slope of the line between those 2 points, or the average rate of change between those 2 points. Okay, that special line that connects those 2 points is called a secant line. Any line that intersects something twice is a secant line. So the formula looks a little different, but remember, f of x is the same as y. So really, I could substitute those f of x's for y's, and it would be the same as the slope formula you've been using since Algebra 1. Okay, so let's look at an example of average rate of change. I don't even need the picture for this problem because I'm going to plug numbers into the function and use that slope formula to solve it. Sometimes you could be able to use the picture and actually count rise over run to find the slope. It just may be difficult sometimes to actually look at. So since they want us to find the average rate of change from -3 to -1, we're going to plug those two values into the function. I'm going to start with f of -3. So when I plug -3 into this function, you could do it several ways. You could just type this into your home screen and find out the value, or you could type the function into y equals and then go to the table and find the two values at the same time. So when I simplify this, I find that f of -3 is equal to -24. Then I'm going to do the same thing for -1. So f of -1, plug that in everywhere there's an x, and simplify. And f of -1 equals 0. So those two answers that I just got are actually the y values. What I plugged in was the x values. So when I find the average rate of change, I'm going to start with the y values. I'm going to do y minus y over x minus x. So -24 minus 0 over -3 minus a -1. So this is going to simplify to -24 over -2, which is equal to 12. So that means the average rate of change between -3 and -1 on this function is equal to -12. Or if I calculated the slope of the secant line, it would be equal to 12. It rises 12 and runs 1.